there's a tide, and we're rotating faster than the tide is sloshing onto and off Earth's surface. The middle of the ocean doesn't care. Where the water moves on our surface, it causes tidal friction. The single place on Earth that is most responsible for tidal friction between the Earth and Moon is the Bay of Fundy.
Okay. Never heard of this.
Southeast coast of Canada. There's a bay where the geometry of the bay is such that the tides, as they come in and out, will rise and fall 50 feet. 50 feet.
That's a lot.
Because there's a channeling of the water as it comes in from the ocean. And as the tide moves in and it gets channeled and narrowed, it's the same amount of water. You give it less volume to occupy. There it is.
It goes up.
And in that channel, they say you can jog alongside the water as the tide comes in.
That's
how fast it's coming in. Talk about friction between the ocean and Earth. That is maximal friction. That friction is slowing down the rotation of the Earth.
Whoa.
Because the tidal bulge is there in space and Earth is trying to turn through it.
Right.
That is causing resistance to our rotation.
And it's actually acting like a little brake pad.
A brake pad. That's exactly.
Yeah, that's wild.
It's putting the brakes on Earth.
Cool.
There's something called angular momentum. If we are slowing down, something has to be gaining angular momentum.
Okay.
If we're losing it.
Right.
I would tell you what it is. It's the moon.
Oh, snap.
How does the moon gain the angular momentum? It's not touching us. It's not.
Right.
You know what it is? Because the tidal bulge that it created is ahead of itself. There's an extra pull of gravity out there that it feels. And it gets pulled faster in its orbit. And if you're at an orbit and your speed increases, you go to a higher orbit.
That is so cool.
It's like we're slinging
the moon
to a higher orbit.
And we're like, why are you leaving? And the moon is like, because you're driving me away.
Literally driving it away.
Wow.
The bulge is sending it to a higher orbit because it feels the gravity boosting its orbital speed.
And it's creating a little brake pad effect here on Earth.
And they're happening in perfect synchrony. Now watch. We continue to slow down. We're no longer pushing the bulge as far ahead of the moon as we once did. Eventually, we're always facing the moon, rotating at the same rate that the moon goes around Earth.
Right.
No longer is the bulge ahead of the moon. No longer is there tidal friction on the Earth. And all tides stop.
And then we are tidally locked.
Double tidal lock.
Damn!
And that's the wrestling move I tried to invent when I was wrestling.
Okay. It's not cool to be